Hello, good evening. Today is Monday, December 28th, 2020, and I'm continuing with the video presentations. So I just want to provide some context. So I started really these video presentations in May of this year, May 2020, until around early December 2020, when I gave a series of keynote addresses while working from home during COVID-19, as well as some panels. So I gave altogether 17 keynote addresses and around, I believe, 11 panels. So I have video presentations of most of my keynote addresses and some of the panels. And so I make these presentations, as I said, just in case there's a technology glitch when I'm actually giving the keynote address. So since December 26th, so 2 days ago, I started giving some video presentations of some important lectures I've given over the years. So on Saturday, December 26th, I gave a talk on malware, in particular reactively adaptive malware. And so that presentation was initially given in April 2013. It was the Polycarp Kush lecture that I delivered at the time. And then yesterday, which is Sunday, December 27th, I gave a talk on data mining for malware detection. And that is based on the book that we wrote back in December 2011. And so I also gave a few keynote addresses, and much of the information presented yesterday was based on the keynote address I gave at the European ISI, European Intelligence and Security Informatics Conference in September 2011. I also added one chart to give a sort of an overview of what has happened since then and what are some of the challenges. So today's talk is going to be on cloud-centric assured information sharing. And so this versions of this presentation were given, I believe, from around 2012-13 until around 2016. And so essentially my charts are the charts I used back then, so almost 4-something years ago. And so I have used versions of the presentation I'm giving today in some of my recent presentations. So not sort of identical, but I've taken parts of this presentation and incorporated them as relevant into some of my new presentations on integrating security and artificial intelligence, as well as Internet of Transportation. And so these are some of the recent talks that I have given. That was, the last few years, 2-3 years, as well as while working from home during COVID-19. Okay, so my talk is on assured information sharing in the cloud, or you can call it cloud-centric assured information sharing. And so I'm going to share my screen. Okay, right. Great. Okay, so although, as I said, versions of this presentation, the original versions were given 2012-13 to until around 2016. So I've used a December 2020 date because, today is December 28th, but I've given history. So outline and acknowledgement. So much of this work was funded by the Air Force Office of Scientific Research. And so here's the history. So we started the work actually around 2005. So I joined University of Texas, Dallas in October 2004. And at that time, the 9/11 Commission report had just come out. And they had talked about information sharing. If only the organizations had shared information, perhaps, 9/11 might not have happened again. it's easy to say after the fact. So no one really knows what would have happened, but still they stress the importance of sharing information between different organizations. So we wrote a proposal to the Air Force, and I invited Professor Ravi Sandhu as a subcontractor. And so he was at George Mason University, and now he's at University of Texas at San Antonio. So this work was carried out between 2005 and 2008. And then sometime around 2006-07, I wrote a one-page that together with another colleague from Purdue, Professor Elisa Bertino. And so we submitted the one paper, and it went into the MURI BAA, the Broad Agency Announcement. That was in 2007. And so I formed a team. And then I asked University of Maryland, Baltimore County, Dr. Tim Finan to lead it. So the mainly I did that was because when I wrote a proposal to NSF in 2006, I got a comment saying that the PI has not been in US academia for a long time because I just joined in October 2004, and then I wrote a proposal in, it was I think February 2006. So I got one of the comments from reviewers. So I did not want that to happen with the MURI. I'd rather get some funding than none. So Dr. Tim Finan is a very well-known researcher in semantic web and artificial intelligence. So he led the project, and then also invited, Purdue, which was, so I was sort of instrumental in forming the team, and as well as some of the sort of the ideas behind this MURI. And so Elisa Bertino and her team from Purdue, and then myself and Murat Kantajulu and our team, we had a very interdisciplinary team from UT Dallas, and Dr. Ravi Sandhu and his team from University of Texas, San Antonio, Professor Jay Han and his team from University of Illinois, Urbana-Champaign. And we had just one person, Lada Adamik, a brilliant professor, PhD from Stanford, and she was at University of Michigan at that time. Now she's working for I believe it's for Facebook. And so we wrote the proposal. Just because your one page goes into the BAA doesn't mean you necessarily win it, but we really worked hard, and we were so pleased to win this proposal. Okay, so that was 2008 to 2013. Then we had another grant from the Air Force Office of Scientific Research, and together I invited Purdue to team with us, and that was what our sponsor used to call mini MURIs. It was not exactly a MURI, but it was a fairly large effort, and that was on secure cloud computing. And then we had another effort that we were funded by the Air Force Office of Scientific Research, Assured Information Sharing. So we developed information sharing in these two efforts, secure cloud here, and in this effort, under this effort, and then information sharing in the cloud. And this was joint research between us and our European partners, Professor Steve Barker, and then Professor Maribel Fernandez from King's College, University of London, and then Professor Elena Ferrari and Barbara Carminati, Professor Carminati from University of Insubria, Italy. They got funding from EOD. EOD is the European Office of, I think, is it Aerospace Research and Development? That is the Air Force Office of Scientific Research as a branch in London, EOD, that they fund efforts in Europe. I think it's Europe, Middle East, and EMEA region, Europe, Middle East, and Africa. And then they also have another organization in AOD, that's the Asia, Office of Air Force Scientific Aerospace Research and Development, I believe, in Tokyo. And they fund efforts Asia Pacific region. And I think they also have a branch in South America. Very likely it's in Argentina. I don't know exactly where in Argentina, whether it's in Santiago, Chile, Buenos Aires. And so anyway, so we had this joint project. And then we also got a bit of funding from National Science Foundation to develop capacity and education and courses. So I also wrote a book on secure cloud computing. So that was more for capacity building, building the infrastructure and the education programs in National Science Foundation. So I do teach a course in secure cloud computing at the University of Texas, Dallas, which also has units on assured information sharing in the cloud. Okay, so this gives a background. Now, as I said, I started this work in 2005, and this work sort of finished around 2016, so around 11 years. I've been working 10 years, and the 11th year we sort of moved into big data. I'm going to talk about it to the last chart. And so it was really a good solid 10 years, maybe a little bit more in this area. And so I've given a number of keynote addresses, history of this particular version of the presentation. So I gave earlier versions, and then this current version I'm giving. And then I'm also incorporating them now into some other versions, which I'm sort of as part of AI and cybersecurity, artificial intelligence, machine learning, and cybersecurity, data science, as well as Internet of Transportation. Okay, so here are some examples. I'm only naming a few. IEEE CloudCom, and that was in 2013. It was in Bristol, England, and it was very special because I studied at the University of Bristol. I got my graduate education. And then it's the Big Data Social Com Cybersecurity Conference in 2014. ASC is the organization that sponsored this event, and it was at Stanford, California. And that was, I believe, in December 2013, May 2014. And then in 2015, August, IEEE Conference of Contemporary Computing in a city called Noida in India. It's close to New Delhi, India. And then in 2016, I gave a keynote. These are all keynote addresses. I gave a keynote address at ACM SACMAT, Symposium on Access Control, I think models and technologies. Anyway, so that was in Shanghai, China. It's a very well-known cybersecurity, data and application security and privacy conference. And then I also gave a version of this in SNAMS, which is Social Media Analytics Management and Security in Vienna. But this SNAMS conference, actually, I need to make a point, because the first three were purely assured information sharing. So SNAMS was, talking about cloud computing and then secure cloud computing. How do you connect it to social media? So I did not use the social media charts in this presentation. I'm going to talk about social media security and privacy over the next few days. So I'm going to continue with these presentations 29th, 30th, and 31st. And then I'll take a short break, 2 days for the new year, and perhaps maybe get back again January 2nd, because I still have another 3 or 4 more presentations to complete on some of the key presentations I've given over the years. Okay, so the technologies discussed in this presentation were developed mainly, as I say, between 2005 to 2015. Okay, so assured information sharing. Different organizations have to share data. What is assured? That means securely sharing the data. And so that was our first grant, remember, 2005 to 2008. So there we said, we have to give incentives to people to share data. And what are the policy-based information sharing? We've done a lot more work now in policy-based data collection, data sharing, and I talk about it as part of my AI and security lectures. So policy and incentive-based information sharing. And so we developed some technology, some algorithms, and we integrated the Medicaid claims data from the state of Texas, all of the identifiers anonymized. And then we use that to sort of analyze for analysis purposes. And then we enforce policies and determine how much information has been lost. So we share data. We also do some data mining on the data. And then, but not all of the data is shared, right? Because it's according to the policies. So what we did was to sort of to measure. So this was myself, Dr. Khan, and our postdoc. He had finished his PhD under Dr. Khan, Dr. Mahmood Award. And so we sort of measured how much information have we lost. So all our policies were based on XACML. I'll discuss the prototype. So because if you're not sharing the information, right, then you're going to lose some vital part of information. But then you cannot share everything, right? So policies have to govern the sharing. So sometimes you might want to share everything and then do an analysis as to the effects. What were the consequences of sharing? And then my colleague, Dr. Murad Kantajlu, he joined us around that time in September 2005, and PhD from Purdue. And so he was doing some work on incentives and risks for information sharing. So he worked with a world famous risk and decision scientist from our School of Management. He was the head of the European Space Agency as well as INRIA in France, Dr. Alain Bensaswan. He had joined us. And so they did a lot of mathematical computations for incentives and risks. And they continued to work also applying game theory and probing to extract information from semi-true. So what I did was to make it sort of understandable as to why we are doing this. So we said, okay, we break it down, our partners, into 3 categories. One is trustworthy partners. So here we talk about, say, maybe between friends, but you don't share everything between friends, right? So friendly countries. So for second approach, where you want to play games, we said, okay, we may not trust everyone. So we may want to play some games with them. So that's second, right? Second approach. And the third approach, we said, okay, there are people that, we don't like, but we still have to work with them, right? And so we have to work with them, but we also have to make sure that we defend ourselves. And we also want to find out what they are doing. So I call it active defense, and determine the actions of an untrustworthy partner, right? So defend ourselves from our partners using data analytics techniques, maybe, and conduct active defense, find out what our partners are doing by monitoring them. And some say, that is not really appropriate. So we've got to be very careful when we do that. Again, now I'm very strongly, we focus on policy-based, information, defending ourselves, and policy-based approach to active defense. Okay, so Dr. Kevin Hamlin, PhD from Cornell, he had joined us in 2006, September. So he was focusing on some of the active defense research areas. Okay, so that's assured information sharing approach. And so for the first approach, right, which is policy-based information sharing, so we developed a prototype, a system. So we have database 1, database 2. These were all Medicaid databases in the state of Texas. We were fortunate to be able to get this data from the state of Texas, from Austin. I think he was the Inspector General at that time of the state of Texas. And so all of the data was anonymized. So we didn't know whose data it was. And we enforced all of these policies in XACML, Extensible Access Control Markup Language. Okay, and so you have, your query, and all of the policies are enforced in XACML, and I'll explain in a minute what types of policies we focused on. And then these, so all of the policies and data are stored in our system that we developed. And then according to the policies, the information would be shared. So what are some of the policies? Okay, and that's something I'm going to come back to later on when we talk about cloud-based information sharing. Okay, so now I'm going to talk about our third project, right? Which is, I'm going to sort of skip our Muri project, right? Muri was sort of a joint effort between all of us. And so there was a lot of incentives-based. What we contributed a lot was incentive-based information sharing. So we conducted many experiments on actually on this point, right? Many experiments on giving incentives to various students and make them share data. And so this was carried out with behavioral scientists. And so behavioral economists determine incentives and risks. And then we also worked on the game theoretical aspect as well as, so that was sort of our focus on the Muri. In addition, we also, on this original project, we conducted the active defense part of the research, as well as we continued with that part later on under some separate grants that we got. Okay, so now I talk about our secure cloud computing. And so this research started around 2008, 2009, so 2008. And so this was really very original because we were sort of one of the early teams to develop and secure a cloud. And so if you look at the layers, a layered based architecture, you have the virtual network monitor. So we didn't really focus on, we said that there is a virtual network which is secure that's provided for us. So we focused on virtual machine monitor, which is the hypervisor, and then cloud storage manager and the cloud data manager and the applications, user interface / applications. And then our application was information sharing. Okay, so now we are developing the cloud. So we develop all those layers, and then the application was information sharing securely. And then you have these policies, and then quality of service. Sometimes you may need security, sometimes performance, and how do you allocate resources. And then we also looked at risks and costs involved, and then monitoring the cloud. So this was our framework, and these were the technologies. So for policies, we had two types of systems. One was based on XACML, Extensible Access Control Markup Language, which is a standard, and the other one is the resource description framework, part of the semantic web technologies. And then, right, so here we had the applications information sharing. We assumed that virtual network was there. We used Zen for the hypervisor. Zen was a system hypervisor developed at University of Cambridge, England, and it was open source, so that's why we chose that. But we could have also, VMware is the most, one of the commercial products which is used by many. And so then we had the Hadoop MapReduce storage for the cloud, and then query processing, the information sharing. The crux of the system was two systems. One was based on Hive. That's a relational database, cloud-based relational database system developed by Facebook, which then they made it open source later by Apache. I believe it's Apache, right? And then SPARQL, that's the SPARQL query optimizer for RDF data. And right, so this was the framework. What is in pink are areas that we could still work on, but what is in blue were sort of completed prototypes. And we are assuming that we have integrated. We are not a systems integrator, right? We are professors, and we want each one of those layers, right? This layer was a PhD student worked on this, and risk analysis, another PhD student, Hive SPARQL query. So this sort of gave us about 4 or 5 PhD theses. And what will be ideal is to integrate all of these layers, right? So that's what we were hoping. Maybe, maybe it's already done because, oh, by the way, we put a 1 page on this for a STTR and assured information sharing in the cloud, I believe. Yeah, that was yes, I think that was the topic or secure, yeah. But and we put in a proposal for the STTR. As I said, just because you have a 1 page doesn't mean you get funded. Unfortunately, we didn't get funded for the STTR. Okay, so that was layered framework for assured cloud computing. Now, secure query processing. I just want to make sure I've got the policies. Yes. So I'll talk about now, before I go into the policies, I want to talk about our the query processing. Later, I'll talk very briefly what we did for the other layers. So I'm going to talk about a Hive prototype. So secure query processing with Hadoop MapReduce. Okay, so we have studied clouds based on Hadoop, right? Now, of course, we've studied clouds now based on Storm and Spark and so on. Query rewriting and optimizations techniques designed and developed, implemented for 2 types of data. One is relational data, and that we use the Hive, the Facebook's relational database system in the cloud. And it's now open source. And then for RDF data, we didn't have anything available. So we had to implement something from scratch. So we call it SPARQL Query Optimizer. And that's something we designed and developed. And then we have the demonstrated with XACML policies, both systems. And then we also shared the data in the cloud jointly with King's College and University of Insubria. The dates are a little bit off, by the way, I'm sorry. First demo was actually in 2012/13, and the second demo was around 2014, okay, multiple clouds. So that was our target to have it in 2011 and 12. So it was really 2012, I would say, the first one, and 13/14 was the second demo. Okay, so fine-grained access control with Hive. So what did we do? Before I come to this, what we did was, we had the Hadoop MapReduce-based cloud, right? HDFS, Hadoop Distributed File System, right? So that was our file system. And then fortunately for us, Facebook had already developed Hive. So that was available. And so all we had to do was still a lot of work. We had to do was to build an XACML-based query evaluator and policy enforcement module. So user will query, this enforcement module will kick in, and it will look at all what the policies are. And according to the policies, the information sends to the databases, and the information is retrieved. And according to the policies, the information is shared. So we had, HDFS is already there, Hive is already there. So we had to design and develop this system. So table view definitions and loading, users can create tables and load data into tables. They can also upload the policies, XACML policies for the tables they're creating. Users can also create XACML policies, tables, views. Users can define views only if they have permissions for all tables. So these are some specifics that we implemented. They can also either specify or create XACML policies for the views they are defining. And we presented this paper at IEEE Collaborate.com in 2010. So it was great for Hive. But then we wanted to do this also for SPARQL, because Hive was great relational database that is structured, right? But we wanted also to work with video sharing, with image sharing, and so on. So we said we wanted sort of to go with the semantic web data. Okay, so it was great with semantic web data. We were able to specify more policies on video data and so on, and image. So we focused actually on images as well. But we didn't have a Hive equivalent. So we used Hadoop distributed file system, HDFS, and then we didn't have Hive, and we had to also implement the XACML policy module. So we didn't have Hive, but Hive was relational, remember. So we had to implement something that was semantic web based, right? So semantic web, in particular, RDF, Resource Description Framework. So we looked at Jenna, which was developed by HP Labs, I believe in Bristol, England. And we tried to see whether it would scale. But we used some aspects of Jenna, but then we had to make sure that the SPARQL query optimizer. SPARQL is a query language for RDF data, RDF, OWL, and so on. It's a semantic web query language, okay? So we had to develop this query optimizer. And so the optimizer, two parts, right? One is the data. So we had to simulate a lot of the data. So we loaded a lot of the LUBM, LUBM, that's Lehigh University Data Simulator. So we used that, and all of the data was arriving and data was pre-processed. So essentially I'm showing, see the difference? I'm showing the functional architecture here, whereas here I'm showing the system architecture, okay? So just to make note, to make sure that we understand what I'm trying to say here. So you have the n triples, right? The data is coming in, and then we break the data, we convert the data, apply some do some prefix generators, and then we split the n triples, predicate-based splitter. Remember, RDF is subject, predicate, object. Tim Berners-Lee is the inventor of the semantic web, or Sir Tim Berners-Lee is the inventor of the semantic web. So predicate-based splitter, and then predicate object-based splitter. So it's sort of in our paper, IEEE Transactions of Knowledge and Data Engineering. It had so many downloads at the time, this particular paper, and so many teams had asked us for the source code, which we, of course, we shared, again, information sharing. On the other side is our policy evaluator, the MapReduce framework. Takes the parser, takes a query, validates and rewrites. So the challenge is to rewrite the query so that we can efficiently execute it, right? Otherwise you could ask, what's the research? Okay, rewriting query is a big part of the research. So, and in this end, splitting the predicates. Splitting the data. So XACML has got policy decision point policies, XACML terminology. And then we take the XACML policies and query rewrite based on the policies, generate the execution plans, and carry out the execution plans from the data that we get from this side, okay? So to build an efficient storage mechanism, Hadoop for lots of data, billions of triples, RDF data, built an efficient query mechanism for data stored in Hadoop, integrate with Jena. So we had to build this optimizer to integrate with Jena, because we looked at Jena had some sort of query facilities, but fairly primitive. So we had to integrate that optimizer and developed a query optimizer and query rewriting techniques for RDF data with XACML policies. And it was implemented on top of Jena. And then IEEE, it was published in IEEE transactions. Okay, so that was great. Now, in order to demonstrate the system, of course, I say policy, 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 but what are these policies? I've got to sort of confess that we, in a way, work with toy policies. Toy means TOY, because we didn't really work with policy experts at the time. Okay, so now our work, we are working with our Dean of the Economics, Policy and Political Sciences, Professor Jennifer Holmes. She's a top-notch policy expert, so she's working with us and helping develop policies. For example, one of my colleagues, Professor Alvaro Cardenas and Dr. Jennifer Holmes, they have a joint proposal from NSF to look at the power grid in the country, Colombia. And so, Dr. Holmes was working on, developing some realistic policies that you can test and so on, right? But then at that time, we computer scientists, right? We come up with some good, sort of techniques and formal programming languages and enforcement techniques and so on, but we don't come up with policies. So that's one of the reasons I'm sort of planning to take the certificate course at the London School of Economics on public policy, so that gives me a better understanding of what these policies are all about, right? I've been working on policies since 1985, 86. We used to call them constraints. I got into cybersecurity in 1985 when I was at Honeywell, and then MITRE, and I was a program director at NSF, and then UT Dallas. So I've got a varied background over the last 35 years. But again, all our policies were like toy policies. So we really, if you're serious about policies, we really need to have an understanding about what these policies are. But anyway, I'm going to talk about my toy policies. Agency 1 wants to share agency resources if agency 2 also shares. So my friend is asking me for something, give me some candy. I'll say, okay, I'm going to give you candy provided you give me something else. So I'll give you a secret provided you tell me something about yourself, right? Agency 1 asks agency 2 for justification. So like John tells Mary, okay, why do you want this information? Why do you want my secret? We justify. Agency 1 shares a resource with agency 2, provided agency 2 does not share it with agency 3. So John tells Mary, okay, I will share the secret with you, but don't tell that secret to Paul, okay? And again, we don't know whether Mary is going to tell the secret to Paul, but we have to do some auditing and accountability after that, just to make sure the policies are not violated. Agency 1 shares resources with agency 2, depending on content of the resource or until a certain time. Agency 1 shares a resource with agency 2, provided agency 2 does not infer sensitive data. So this is an inference problem. Actually, next week, I'm going to talk about all of my work that I've done on the inference problem, going back to 85, 86, and I think I finished this particular inference problem work. It's still, I'm doing it to some extent with the privacy work. So essentially from about 2015. So I would say over a 30-year period, I've contributed quite a bit to this inference problem work. So essentially, why I discuss this policy is because if, say, you want to share data, right? Say the two agencies want to share data. And then, you need to actually, emergency situation, you may want to share the data. And then you may want to do a quick check by sharing, or even before sharing, quick check. Can agency 2 infer some highly classified information if I do share the data? So you can build an inference controller very rapidly. And these days you can do things very quickly, right? Because you've got all the processing capabilities. And then you also have big data processing, because at that time, when I was doing the work in the 1980s and 1990s, we didn't have all these processing capabilities. So that was sort of my plan. Agency 1 shares a resource with agency 2, provided agency 2 shares a resource only with those in its organization or within their social network, right? So that was another type of policy. Okay, so we demonstrated. This was our first prototype, 2012. I remember 2012, September. Three agencies, and they are sharing data, the user interface. So we had both prototypes, right? Both query processors, fine-grained access control, XACML policies with Hive relational data, and then our SPARQL query optimizer for RDF data. And so we demonstrated, and then we found, we had only one cloud. It was in Dallas. And so we found that the performance was actually not very good. So we said, why? So then I thought, okay, we have XACML policies, right, in XACML, and data here is in relational tables, and data is in RDF. There's an impedance mismatch. XACML is based on XML. So I said, okay, why don't we make everything RDF to see whether we can do things more efficiently. So in order to do that, I've got to build now a policy engine. Remember, we had built all the XACML policy evaluators and so on. So I had to build the XACML policy engine. But I like reusing stuff, right? So fortunately, I had a PhD student who was actually working on data provenance, Dr. Tyrone Cadenhead. And he also was a postdoc after that. So he developed some systems for me, actually some of these prototypes. So, and together with another PhD student, he's now Dr. Vaibhav Kadilkar. So both of them developed some of this work. They did actually a lot of work. RDF-based policy engine is what Tyrone, my Dr. Tyrone Caden had developed. So remember back in 1990s when I developed the inference controller, we used secure Sybase, and we had to implement all of this inference engine. The policies were all implemented in C programming language, relational database, and it took us like over a year to develop this policy engine, probably about 1+ years, like 1 to 1.5 years, 12 to 18 months. But as I wanted to do the same experiment, I didn't sort of have assured information sharing in mind at the time. So I asked Tyrone, why don't we do a inference controller? Why don't we develop? So he developed this probably in about 3 months, right? So we used RDF for our database and RDF data, and the policies, ontologies, rules are all in RDF. We also use SPARQL, SPARQL as well as swirls, semantic web rules language, and OWL, and so on. And then we used University of Maryland College Park's Pellet, I believe it's College Park, for our inference engine. And we had to put together all the systems. It was not just very straightforward integration. We had to do some work in this implementation. So we built an inference controller. And so in fact, part of this actually went in as part of our book on secure data provenance and inference control with semantic web data that was published in 2014, I believe. Okay. So I said, we already have this policy engine. Why don't we re-implement it in the cloud? Re-implement is very important. You can't just take the policy engine and just put it in the cloud on one node. Then you don't take advantage of any of the features offered by the cloud. So what Tyrone and Vaibhav, so now they're Dr. Tyrone and Dr. Vaibhav, what they did was to take the RDF-based policy engine, you've got to re-implement because you've got to take advantage of the cloud. That doesn't mean you have to implement line by line. You take modules and re-implement and try to fit it in the cloud, take advantage of the cloud data storage and all of the various Hadoop distributed file system and MapReduce programming. all of that have to be taken into consideration. And so we re-implemented. So a testbed for evaluating different policy sets over different data representation, also supporting provenance as directed graph. So we had RDF data for provenance data. That was sort of our experimental data. So determine how access is granted to a resource, well as how document is shared, user specified policy, access control, redaction, release policies, pass a high-level policy to a low-level representation, support graph operations and visualization, policy executed as graph operations, execute policies as SPARQL queries over large RDF graphs on Hadoop, support for policies over traditional data and its provenance. And so we presented this implementation at IFIP Data and Applications Security Conference in ACM SACMAT 2000, sorry, IFIP Data and Application Security paper was in 2010, and also as ACM SACMAT in 2011. And then we also had some other conference papers based on this information sharing work. Okay, so this particular policy implemented in the cloud. Okay, so that we presented. Then this was our big sort of debut with the integration with assured information sharing. So multiple clouds, it could be in London, it could be in Dallas, it could be in Italy. And so we had multiple agencies, and typically we said London, Dallas, and Italy, or Dallas, London, and Italy. So we had, everything was in RDF, right? This was our policy engine, data engine, the whole lot. So we had our SPARQL query optimizer, remember policy translation, transformation, MapReduce framework. Sorry, SPARQL query optimizer is these two parts, RDF data processor and MapReduce framework for query processing. And then we have the Hadoop, GenAverse database. And then we have the policy translation and transformation, which is essentially this whole part, fits in right here. And then we demonstrated this system. Okay, so this was really a huge achievement at the time. Okay, so then now I'm going to talk about some bits and pieces of work that we did, and we are still doing some of the work. So this part, assured information sharing was really, in a way, I look at it as my sort of baby, in the sense that that was really my responsibility for the projects. And so my colleagues, if you remember, it was a team effort, and they did a lot of work as well. So for instance, so before that, I had a question. So we looked at can we apply this technology for emergency preparedness? Okay, so extending the work to, so what we are saying is we can use social networks for crisis management, say hurricanes and war, reconstruction after a war, and thunderstorms and tornadoes and 9/11 type of stuff. And of course, today we have COVID-19. Okay, that's a dreaded thing that we're all going through. Okay, so what we said was, can we sort of apply this to multiple agencies, all part of social networks, and how can we bring in social networking technology together with the technology that we have developed? This is just a question. We really wanted to do this sort of work, but we didn't really have funding at the time for this, and also we wanted to move on because we've done a lot of work on social media analytics and social media security and privacy. And then the big question is, how do you share information among various members in the social media? And now we moved on to topics like social media governance, what I work on, and detecting fake news. So those are some of the areas that I'm interested today. And hopefully sometime early part of next year, I can, I'm going to give some presentations on social, on fake news and social media governance and so on. Okay, but I'm going to give a talk on analyzing and securing social media. Probably that will be my topic, not for Tuesday. It'll be my topic for Wednesday. Okay, so my colleague, Murat Kantarjalu, worked with, Dr. Murat worked with the University of California, Irvine, with Professor Sharad Mehrotra, and I contributed a little bit to this. So how do you store the data in the cloud? And they were focusing on hybrid cloud, because hybrid cloud is that you have a private cloud, and I don't want to sort of go into a big discussion on cloud computing, but private cloud is something like organizations, they don't want to put their sensitive data, financial data, healthcare data. You don't want it to go on the public cloud, like Amazon AWS, right? Amazon EC2 or Amazon Web Services, no, because it's private, right? But you want to take advantage of what Amazon is providing or other public clouds are providing. So some data you want to store in the public cloud and some data in the private cloud. How do you decide which data? Of course, you would like to put everything in the public cloud because there'll be little expense. Or sometimes you may want to put more in the private cloud because you're going to build the private cloud anyway. So you might want to minimize putting stuff in the public cloud because you still have to pay for the cloud, right? So there's a trade-off. So what data do you put in the public cloud and what data in the private cloud? The use of hybrid clouds is emerging. Even IBM has said back like 5 years ago, public cloud is the way to go. Ability to exploit public resources for high throughput, yet better able to control costs and data privacy. Several key challenges: data design, how to store data in a hybrid cloud. So a solution must account for data representation, use encrypted public cloud monitoring costs and query workload characteristics, and query processing, how to execute a query over a hybrid cloud. Solution must provide query rewrite rules that ensure the correctness of generated query plan over the hybrid cloud. So we do computations in terms of cost. So we look at cost and security, right? This trade-off: utility, cost, and security / privacy. Because you don't want to sort of mask the data until it becomes useless, right? So utility is important. And of course, you don't want cost to be just exorbitant price, but you want also to have, of course, security and privacy is our major goal. So looking at trade-offs, one thing I wanted to mention, and I'm sorry that I want to, it's very important that I didn't, and I want to add this so that it's there, part of the history. So we said, remember education. I also got an IBM faculty award. I really want to thank IBM because they also supported us. 2000 faculty award for secure cloud computing, education, or curriculum development. Yes. Gosh, I wanted to do this because it's going to go on video. So please bear with me. Curriculum 2013. And so this is really important. Okay, so, okay. Okay, so I really wanted to mention that. So this is something that is very important, and then to make it a little bit organized. If I can just move this, otherwise it's okay. Okay, great. So that was also one of our sponsors for our work on cloud. Great. And then I want to go back. How do I go back here? We finished all this. I want to go to the public cloud part. Okay. So essentially what we are doing is three things, right? Cost, utility, security / privacy, to decide which data to go in the public cloud, which data in the private cloud. Okay. Then remember we said cloud monitoring, right? What do? So we used Zen for the virtualization hardware. So that's the hypervisor. Remember, what is interesting about cloud is that the whole idea of virtualization, you don't have to have virtualization, but virtualization helps. That means you can, what is virtualization? You can put in, say, let's say this is a Windows machine, right? Then you can throw in a Linux operating system, Solaris, XP, Mac OS, and then it's say another Windows, I don't know, 10, whatever. And so the thing is, so multiple operating systems, but again, only one physical operating system. So all the resources have to be shared. But imagine when you have all these multiple systems, they could all corrupt each other. And that's where VMware or Zen or vSphere virtualization layer comes in. It ensures that there is separation between these, host operating system is, say, Windows in this particular case, and guest operating systems like Linux, Solaris, and Mac OS, and so on. Of course, you have the hardware. Applications, operating system, hypervisor. This is the work of two people, Dr. Jichang Lin, who was a team member. Now he's at Ohio State. And by the way, earlier when I said Dr. Alvaro Cardenas, he's now University of California, Santa Cruz. And then also Dr. Kevin Hamlin. So cloud integrity and forensics. And again, the whole idea is who does all the monitoring of the cloud? Does the hypervisor do it? Then hypervisor has to monitor all of them. And what happens if the hypervisor is attacked? Or does each of the operating system, should it have its own monitor? And so minimize the work of the hypervisor. So secure control flow of hypervisor code, and then integrity via inline reference monitor. That's applying some formal methods. That's Dr. Hamlin's work, and also mainly Dr. Lin's work in terms of the monitoring and looking at sort of the trade-offs and doing binary code analysis and so on, and forensics data extraction in the cloud. That's another aspect. And so right, so virtual machine monitoring, right? That's the whole crux of the idea. Okay, so the other part that we did was, this is again Dr. Latifa Khan and Dr. Mehdi Masood. I talked about Dr. Khan and Dr. Masood's work yesterday on data mining for malware detection. So the whole idea here is, okay, up to this point, we talked about cloud security. Cloud must be secure. But we can also apply cloud technology for security applications. So that's different. Secure cloud means, I talked about the layered framework, and every layer has to be secure, the integration has to be secure, but we can use the cloud for a number of applications, right? For healthcare applications, for financial applications, but we can also use the cloud for security applications, such as checking our emails, or identity and access management, or checking to see if there's malware in our systems and emails and so on, right? And so, because there's lots and lots of security data, and we are developing all these data science, machine learning, data mining techniques. And wouldn't it be great if we can use a secure cloud for security applications so that we can also have speed, right? Cloud will give us performance. So if the cloud is attacked, then forget it. So assume that's why we need a secure cloud. But then we are also applying it for security applications. So yesterday I talked about ensemble of classifications, stream-based novel class detections, a stream of known malware, benign executables, they're all coming in. And then we are doing features extraction and selection. We do training, we develop an ensemble of classification models, and then we classify. On the other side, unknown executables come in, we extract features, and then is it benign, right? Is it benign software, or is it malware? And then we have to remove or quarantine. Benign means fine, we keep it, right? So this is our algorithm essentially, and it's highly novel. And I talked about it in my presentation yesterday. And so, but now we are re-implementing this entire algorithm, stream-based, novel class detection, and we are implementing this entire data science, data mining, machine learning algorithm in the cloud, right? So re-implementing. And to see the performance. So binary feature extraction involves enumerating binary engrams from the binaries and selecting the best engram. I talked about it yesterday, based on the information gained for a training data with 3,500 executables. Number of distinct 6 grams can exceed 200 million, not millions, million in a single machine. This may take hours, depending on available computing resources, not acceptable for training from a stream of binaries. Right? So we use cloud to overcome this bottleneck. So it's so much more efficient for us. So we use a cloud MapReduce framework is used, right? Hadoop MapReduce, to extract and select features from each chunk of data as they arrive. So we have a 10 node cluster. We need to upgrade. 10 node cloud cluster is we found it was 10 times faster. And our paper, we published it in ACM Transactions on Management Information Systems. And 10 node cluster is 10 times faster than a single node, very effective in a dynamic environment where malware characteristics are changing rapidly. So in my yesterday's presentation, even the day before, I was focusing a lot on malware, and malware that is changing patterns is becoming a huge problem, mutating. And that's what we are hearing now of COVID-19, right? How rapidly it's mutating. In some people, it's mutating like much faster. And then in some people, it's not mutating as much. So they describe, and that's what's happening. And yesterday I explained very, I think I did, not yesterday, day before yesterday, I think it was on malware, reactively malware that is changing patterns and mutating. So in one of the articles I read today, actually, they are saying that it's almost like when it goes into the body, right? Like you go into a dressing room, right? And you come out completely, overhaul yourself, completely new outfit, new hairstyle, new, everything new jewelry or tie or whatever. So you completely transform yourself and you come out. That is what is happening with this coronavirus, SARS-CoV-2 in some people, okay? But in some others, it's not mutating as much. It's just like changing the hat or changing the scarf, right? Some minor cosmetic change. So, and they don't know why this is happening, so they're trying to study why some people it's mutating like 23 times, they said, but in some people it's mutating 2-3 times. So when it mutates 23 times, it could be a completely different type of malware, which is what is very scary for me, because are these vaccines going to work, right? But without these vaccines, right, what are we going to do? So I am going to take I know I'm digressing, but that's, this is life or death happening outside. So, and for me, especially working in malicious software and so on, drawing analogies it's so important. And so what I'm saying is, something better than nothing. It can at least prevent me from, getting COVID from, maybe the original SARS-CoV-2 virus. Not maybe the completely mutated version, the one that has completely mutated, although they are saying that the vaccine should work. So essentially, I'd much rather have the vaccine and protect me from something. Of course, as long as I know that, I don't want to have a false sense of security, then not have a vaccine. So that's what analogy is that, of course, it'd be wonderful to have antivirus products that can handle all types of mutations. That's what we're striving for. Because malware is also using data mining to mutate itself, because it doesn't want to mutate in a pattern where it can be caught. So it's looking at the antivirus database and looking at what are the patterns, and then it's going to mutate. And we have to catch it, right? So we have to be several steps ahead of it. So that's the thing. So, but the thing is, just because it's mutating, do you want to throw away the current antivirus products? Absolutely not, right? That's what I'm saying. So yesterday I explained, antivirus products are essentially our vaccines, right? So just because it's mutating, do you want to throw away the vaccines? No, because the vaccines are still going to protect us against some forms of the virus. And also it could maybe even protect us with a mutated virus, right? Maybe slightly mutated. I'm not a infectious disease specialist. No, am I a epidemiologist or sort of a biological scientist? But those are the things I'm saying. We are trying to do also in cybersecurity, because just because malware is mutating, no point for us to apply the current antivirus products. Because we need to develop new products. Then the existing viruses, malware, because they would be they would not be caught, right? So we really need to have all the protection that we can have. And that is what I'm saying. And now I understand why my doctor is always saying, because I'm sort of a bit nervous to go and get my flu vaccine, mainly because, I don't want to go to a hospital or my doctor's clinic, right? That I might get COVID, which is a real danger. So, but I can understand why they want us to take all the flu vaccines, because they want us to be well protected so we can handle, flu. Because what's the point in getting flu and getting weaker? So then we might get COVID, and that could be deadly for us, right? So that's why get those vaccines. And the same thing I'm saying here, get all the antivirus products that you can have. But the main point, that was my yesterday's presentation. Main point here is that we are using the cloud to improve the speed, because we need to rapidly detect, right? That is the challenge. And the cloud is providing. So here we say cloud is providing us with security as a service. just like it's providing us with infrastructure as a service, data as a service, sorry, infrastructure as a service. It provides platform as infrastructure is all the hypervisor, the operating systems, and so on, and the hardware. The platform as a service, maybe with databases and programming environments. Software as a service, maybe to compute our taxes, maybe to share information, all of that it's providing. And then security as a service that cloud can provide, which is, malware detection and so on. It's providing security. And in some cases, it can also provide us with data as a service, because scientists can use the cloud now to store their data and share data in the cloud, right? So this is really important, assured information sharing in the cloud, not just for agencies, but even scientists can share data, and according to policies, because you may not want to share all of your data with everyone, right? Because those who gave you the data, they would have their own policies. So they say, make sure that you don't share all of this data, right? Because you have paid for the data. And so the data owners may want the others to also pay and get the data. So there are policies. So you've got to abide by the policies. Okay, so a few more charts. Identity management considerations in a cloud. So trust, so we need a trust model that handles various trust relationships, access control policies based on roles and attributes, real-time provisioning, authorization, auditing, and accountability. All of that have to be investigated. And there's quite a bit of work on IAM, identity and access management. There are commercial products. Several technologies are being examined to develop the trust model, mainly service-oriented technologies, standards such as SAML, Security Assertion Markup Language for identification and authentication, and XACML, Extensible Access Control Markup Language. This is for web services, for access control, for authorization. And these technologies have been applied and implemented in the cloud, right? For cloud access control and identification. And identity management technologies, there are like OpenID and various products that are standards and products coming out. And the question is, does one size fit all? It's pretty much now SAML and XACML, but is that sort of the way to go? That's the way it seems today, but does one size fit all? Can we develop a trust model that will be applicable to all types of clouds, such as private clouds, public clouds, hybrid clouds? Identity architecture has to be integrated into the cloud architecture. Okay, so all of this identity management system, so there has to be identity management integrated with the cloud architecture. Okay, so that means, so the whole point that I'm trying to make, again, I want to sort of make a distinction. So I'm saying that to access the cloud, you have to, give your identity, right? You have to get, you have to be authenticated, right, to access the cloud, because you are storing all of the stuff in the cloud and you are using the resources that the cloud service provider is giving you. So you just can't just go and access the cloud, right? You need to be authenticated, right? And then you need to have the proper authorization to access all of the resources in the cloud. So this is identity management for a cloud, or in a cloud, or for a cloud, or whatever. That's what I'm talking about. On the other hand, just like cloud has to be secure, I said, right? Secure data, secure networks, secure storage, and so on. And then part of it also IAM, identity and access management. On the other hand, cloud, you can delegate the identity and access management of a company to the cloud. Okay, so that's different in the sense cloud is providing the company with a security service. And what is a security service? Identity and access management. So when you want to access all the company's resources, the company has contracted it to a cloud, or there is a private cloud in the company, and that cloud can make sure that you have the proper authorization to access the resources in the company. There, the cloud is providing identity and access management as a service to the company. Company is a service consumer. Just like in this picture, right? Of course, the cloud has to be secure. The cloud itself could be attacked, right? So we have to come up with appropriate techniques to make sure the cloud is not attacked, or if the cloud is attacked, we have to make sure that we can detect it, right? But the cloud itself can be used for various data science for malware applications, right? So that it can can enhance the performance. Similarly, so that's here. Cloud is providing security as a service, which is malware detection. Here, we are talking about the cloud. To access the cloud, you need to have identity. You need to access the cloud, the cloud, there has to be identity and access management, right? You need to be authenticated, and then you have to make sure you can access the resources in the cloud. On the other hand, the cloud can be used to provide identity and access management for the company. In that case, the latter case, cloud is providing, right, identity management service, security as a service. Okay, so that's different from what I'm trying to say here, but we need to understand both aspects, right? So cloud has to be secure. Cloud can provide security as a service. Okay, so I just want to put that at the end. Okay, so now from cloud to, of course, now we are talking about big data, security, and privacy, right? So I organized a workshop. That's going to be my topic actually it could be for tomorrow. So 3 more topics I want to discuss this, over the next 3 days. So I organized an NSF workshop on big data, security, and privacy, September 2014. And we discussed many aspects: secure storage and infrastructures, how can technologies such as Hadoop and MapReduce be secured, secure data management, techniques for secure query processing. Then we also talked about big data for security. How can we apply all the big data analytics, secure data science for malware analysis? And what about the attacks on big data and analytics, right? That's the adversarial machine learning. And then what are the regulations, compliance, governance? What are the regulations for storing, retaining, managing, transferring, and analyzing big data? Are the corporations compliant with the regulations? Privacy of the individuals have to be maintained, and not just for raw data, but also for data integration and analytics. And the roles and responsibilities must be clearly defined. Okay, so those are some of the things that we discussed, and I will talk about it in my presentation, I believe. Yeah, I'll talk about that tomorrow. And directions, this was the directions as of 2016. Cloud security, of course, we need to continue with the work, right? It's not by any means done. As new clouds are introduced, of course, we've got to focus on secure VM virtual machine monitor, secure virtual network monitor, designing secure Zen virtual machine monitor and other types of virtual machine monitors, and develop automated techniques for virtual machine monitor introspection, hypervisor monitoring, right? I showed a picture earlier. Determine a secure network infrastructure for the cloud data storage, identity management in the cloud, and some of the emerging technologies. So tomorrow's topic is big data, security, and privacy. That's going to be December 29th. Analyzing and securing social media is going to be December 30th. And security and privacy for Internet of Things. In particular, I'll talk about Internet of Transportation and some of the other things. I haven't really, this is an area that I'm still, learning and doing research. So that's something I'll talk about it also on the 31st. And one more thing I wanted to mention, and so if you all don't mind, I want to add that. Okay, so essentially, I know I shouldn't be doing this, but again, it's very important. A point, please note, the point to note, let's put. There are 2 aspects, okay? One is securing the cloud. Other is using the cloud, and I'll say hopefully secure cloud, right? You don't want to use any cloud. Okay, resulting from 1, so I'll put 1. Resulting from 1, okay, other is using the cloud, hopefully a secure cloud resulting from 1, to provide such as malware analysis, Okay, identity and access management. Identity and access management for a identity and access management for a corporation. Okay, and to provide security services such as malware analysis or email analysis, email spam detection, that's better. Called security as a service. Okay, so one is securing the cloud, example, secure Hadoop, secure network, secure network monitor, secure virtual machine monitor, monitor. Then you can have secure data storage, cloud data storage, secure cloud query processing, right? And policy enforcement. And then also remember identity and access management for the cloud. So this is something that I really want you all to make a note. So I just want to increase the size of this too. Okay. So the other, hopefully a secure cloud from one to provide security services such as, and then I'm going to put a, just like that, malware. So I'm going to also put this to 28. So it's all, okay, point to note. Okay, so I'll just say important point. Okay, so that way I just wanted to make sure, sorry, I didn't have this earlier, but as I was explaining this, this came to my mind so that we have, right, so we just want to make sure the spelling is all okay, right, fine. So, so you can see, I just want to show the last one. Just a minute so that it reads very well. Okay, so again, important point to note, there are two aspects. One is securing the cloud, like secure network monitor, secure virtual machine monitor, secure data storage, secure cloud query processing, policy enforcement, identity and access management for the cloud. Other is using the cloud, hopefully a secure cloud resulting from one, right? So to provide security services such as malware analysis, identity and access management for a corporation, email spam detection, and so on. It's called security as a service. So one thing I'm just going to put resulting from one, and this is secure network, secure virtual network monitor. Secure virtual network machine monitor. Okay, so this is what I really wanted to mention. And I think what I want to do is so that, okay, put this in here. Okay, I just want to put this here. So that's, so this way I think we will know. So after I talk about identity and access management, I'll just talk about important point to note. And then we have from cloud to big data security and privacy, and then so directions. So the next 3 lectures is going to be on these 3 topics. Okay, so I'm going to stop sharing. Okay, and so, okay, so essentially I addressed a very important topic, which is I talked about secure cloud computing. So, I sort of was telling a story essentially, right? Where we have come. So we started with a very sort of exploratory project on assured information sharing. And then we had the MURI, and then we had secure cloud computing. Then I combined the MURI work, assured information sharing with cloud, for cloud-centric assured information sharing. And then I also discuss some other topics such as providing security as a service and hybrid data storage. And so this is not the end. I would say that this is just the beginning, right? We have, although I've devoted 10 years of my life, my professional life to this work, 10, 11 years, and I'm still working in this area, right? In terms of big data, that's what I'm going to talk about tomorrow. Lots of the things that we have done on various aspects of big data, security, and privacy. And then I'm also going to talk about, some other things the next day on social media, security and privacy, and analytics. And then also on Internet of Transportation, on policy aware privacy. So putting all that together, and that's going to be the topic for Thursday. Okay. So, and again, I just want to leave you with something, as I said, malware. That is sort of the dreaded thing for us cybersecurity specialists, right? Because again, we are working from home, right? Most of us have been working from home for 9 months now, and we don't know how much longer we are going to work from home. At least probably another 9 months is what I'm thinking. I hope, everything will be fine in 9 months, but who knows, right? Because especially with these mutations, we also got to be realistic. And so, so what I'm saying is that we are depending so much on technology, right, today, because if not for technology, imagine, could we have worked from home, right? We may have had to go to work and we could have died, or we could have, stayed at home and gotten bankrupt, right? So with technology, we are able to do so many things. But remember, as these technologies are being developed, there is this huge problem, right? Technologies can be attacked. And so this malware is this dreaded kind of sort of a curse for cybersecurity specialists, because we've got to be constantly sort of searching for solutions to handle this huge problem. Just like the medical researchers and the biological scientists and the biochemists, they have to be constantly working, right, to get rid of these viruses, right? And hopefully we will all be successful. But what I'm saying is the work never ends. And that's sort of the good news and bad news. Bad news is that there's, we can't say, okay, it's all fine now, nothing's going to happen, so we can all be happy. No, we have to continue working. But the good thing is there are so many challenges. So every day I'm so passionate about the work because there's so much work that we have to do. Okay, so again, thank you very much for listening to this presentation. By the way, I'm Bhavani Thuresingam from the University of Texas at Dallas, and I will be posting my presentation on my YouTube channel, where I posted all the presentations since that I've given while working from home during COVID. And before that, I only had just one presentation that I gave back in 2018, a distinguished lecture presentation, which I, at the university, which I then broke. At that time, I had to break it into 3 parts because we didn't really have the technology to put a 1-hour presentation, right? And so 3 parts, and so it's a 3-part presentation. So next week, I'm hoping to sort of redo that presentation as well. And so again, thank you very much for listening to this presentation, and please be safe. And again, thanks. So I'm going to end this recording.